Look around you. What do you see? A chair, a book, maybe even your pet dog? Everything you see, touch, and even smell is made up of something truly amazing matter. From the smallest grain of sand to the largest star in the cosmos, matter is the building block of our universe. In this journey through the fascinating world of science, we'll uncover the secrets of matter. We'll explore its different forms and how it constantly changes. Get ready to see the ordinary in a whole new light. Everything around you. So, what exactly is matter? In the simplest terms, matter is anything that takes up space and has weight. That means your phone, your pencil, the air you breathe. They're all composed of matter. Imagine a balloon. When it's empty, it's floppy and light. But when you fill it with air, it becomes firm. That's because you've introduced matter, air, into the balloon. The air takes up space and gives the balloon its shape and weight. Matter is everywhere, even in places you might not expect. Understanding matter helps us understand the world around us. And that's a pretty exciting thought. Matter exists in different states, each with unique properties. Let's start with solids. Think of a rock, a wooden block, or a metal spoon. These objects are rigid and hold their shape. That's because the tiny particles within them are tightly packed together, like a crowded room of friends. In solids, these particles can vibrate but can't move freely. This tight arrangement gives solids a fixed shape and volume. Whether you put a rock in a jar or on a table, its shape and size remain the same. Understanding solids helps us build strong structures, design useful tools, and even understand the very ground we walk on. Now, imagine pouring water into a glass. Unlike the rigid rock, the water flows and takes the shape of the container. That's because water is a liquid, the second state of matter. In liquids, the particles are still close together, but have more freedom to move around. They can slide past each other, like marbles in a bag. This is why liquids can flow and change their shape easily. Liquids are essential for life. We drink water, rivers flow across the land, and rain nourishes our planet. Learning about liquids helps us appreciate the vital role they play in our world. Section 5. Air we breathe. Exploring the gaseous state. Take a deep breath. Feel the air filling your lungs. Air, though invisible, is a crucial example of the third state of matter. Gas. Gas particles are much farther apart than in solids or liquids. Imagine a vast playground with kids running around freely. That's similar to how gas particles behave. They move quickly in all directions, bumping into each other and the walls of their container. Gases have no fixed shape or volume. They expand to fill whatever space they occupy. From the air we breathe to the vast clouds in the sky, gases are all around us. Section 6. Plasma, the fourth state of matter. Beyond the familiar states of solid, liquid, and gas, there's a fourth state, plasma. This state is less commonly encountered in our daily lives, but is incredibly fascinating and significant. Plasma is a superheated matter where some electrons have broken free from their atoms, creating a soup of charged particles. Imagine a dance floor with flashing lights. That's plasma. The particles move energetically, creating a dynamic and vibrant state. Plasma is found in stars, lightning, and even fluorescent lights. These everyday examples show how plasma is more common than we might think. The sun, a giant ball of hot plasma, is a prime example. Its surface is a seething mass of plasma, constantly in motion. Its immense energy comes from the constant fusion reactions happening within its plasma core, where hydrogen atoms fuse to form helium, releasing vast amounts of energy. While plasma might seem exotic, it's the most common state of matter in the universe. From the smallest spark to the largest star, plasma is everywhere. Studying plasma helps us understand the stars, develop new technologies, and unravel the mysteries of the cosmos. It plays a crucial role in fields like astrophysics, fusion energy research, and even in medical applications. Section 7. Changing states. From ice to water to steam. One of the most fascinating things about matter is its ability to change states. This ability is fundamental to many natural and industrial processes. Think about what happens when you heat an ice cube. The solid ice absorbs heat energy. The ice, a solid, melts and transforms into water, a liquid. This is because the heat energy causes the molecules to move faster and break free from their fixed positions. This process is called melting. It is a common phenomenon we observe in our daily lives. Continue heating the water and it starts to boil, turning into steam. The liquid water absorbs more heat energy. Steam is water in its gaseous state, also known as water vapor. The molecules are now moving very rapidly and are far apart. This transformation is called vaporization or boiling. Cooling reverses these processes, bringing the molecules closer together again. Condensation happens when water vapor in the air cools and changes back into liquid water, forming those tiny droplets on a cold glass. This is the reverse of vaporization. Freezing occurs when liquid water cools and becomes solid ice. The molecules slow down and arrange themselves into a fixed, orderly pattern. These changes in the state of matter are happening all around us, shaping our world in countless ways. From the water cycle in nature to the functioning of household appliances, understanding these processes is essential. Section 8. Latent heat. The hidden energy. Have you ever noticed that ice melts at a specific temperature, 0 degrees Celsius? This is a well-known fact, but have you ever wondered why it happens at this precise temperature? And water boils at 100 degrees Celsius? Again, this is a common observation, but the underlying reason is quite intriguing. There's a fascinating reason for this, and it involves something called latent heat. This hidden energy plays a crucial role in these phase changes. Latent heat is the hidden energy absorbed or released during a change in state. It is not detectable by a thermometer, yet it is essential for the transformation. When ice melts, it absorbs heat energy from its surroundings to break the bonds holding the water molecules in a rigid structure. This process requires a significant amount of energy. This absorbed energy is the latent heat of fusion. It is the energy needed to change a substance from solid to liquid without changing its temperature. Similarly, when water boils, it absorbs latent heat of vaporization to overcome the forces holding the liquid together and escape as a gas. This energy is crucial for the phase transition. Understanding latent heat is crucial in many applications, from designing refrigerators to predicting weather patterns. It helps us grasp how energy transfer works in various systems, making it a fundamental concept in science and engineering. Section 9. Sublimation. From solid to gas, skipping liquid. Sometimes matter takes a shortcut, transitioning directly from a solid to a gas without passing through the liquid state. This intriguing process is called sublimation. Imagine dry ice, which is solid carbon dioxide. At room temperature, dry ice doesn't melt into a liquid, but directly turns into a gas. That's sublimation in action. Another example is the disappearing act of mothballs in your closet. Sublimation plays a role in various natural phenomena, from the formation of frost to the erosion of glaciers. It's also used in everyday technologies like freeze-drying food and creating special effects in movies. Section 10. Conclusion. Keep exploring the wonders of matter. From the tiniest atoms to the vast expanse of space, matter is the essence of our universe. We've journeyed through the different states of matter, solid, liquid, gas, and plasma, and explored their unique properties. We've witnessed how matter constantly transforms, changing states through melting, boiling, condensation, and freezing. And we've uncovered the hidden energy of latent heat and the intriguing phenomenon of sublimation. As you continue your exploration of science, remember that the world around you is a constant source of wonder and discovery. Keep asking questions, keep experimenting, and keep marveling at the extraordinary nature of matter.